How is a spherical cap formed on a sphere? Imagine holding a globe in your hands and slicing it with a flat piece of paper. The part that sticks out above the cut is what we call a spherical cap. That's how a spherical cap is formed on a sphere. When you cut through a sphere with a flat plane, you create a circular boundary where the plane intersects the sphere. The part of the sphere above or below that boundary is the spherical cap. It's like taking a slice of an orange or a watermelon, but in 3 dimensions. The size of the cap depends on where the plane cuts through the sphere. If the plane slices very close to the top of the sphere, the cap is small. If the plane passes through the middle, the cap becomes a hemisphere, which is half of the sphere. The height of the cap, which we call h, is the perpendicular distance from the plane to the top point of the sphere. The radius of the entire sphere is r, and the radius of the circular boundary created by the cut is a. To picture it better, think of a ball and a flat surface that touches it at some point. The flat surface slices through the ball, creating a flat circular edge. The part of the ball that is above that edge is the spherical cap. The cap's volume can be calculated using a specific formula. It involves the height of the cap, the radius of the sphere, and the mathematical constant pi, which is approximately 3.1416. The formula for the volume of the cap is 1/3 times pi times the square of the height times the quantity 3 times the radius minus the height. Spherical caps are seen in many real-world situations. For example, water droplets on a surface often form spherical caps. The curved surface of lenses and domed roofs also resembles a spherical cap. In astronomy, the visible part of a planet or star that is cut off by the horizon or shadow is a spherical cap. Understanding how a spherical cap is formed helps in calculating its volume and surface area, which is important in engineering, architecture, and physics. So, in simple terms, a spherical cap is created when a flat plane slices through a sphere, leaving a curved surface on one side and a flat circular boundary where the plane intersects the sphere. Its size and shape depend on where the plane cuts through the sphere, and it can be described mathematically with formulas that relate the sphere's radius and the cap's height.